Okay, what we're talking about today is going to be finding the real number system and also properties. So the very first thing we're going to talk about is what is a real number. A real number is any possible number that you can think of in the entire world. The way we denote that is 2 lines down, and then you're going to make an R out of it. That is the real number system. That is what you will hear me all the time refer to it as. The real number system is going to be 2 lines down with an R through it. And the irrational number is going to be a number that does not make any sense to you. It's a number that can't be expressed as a fraction. An example of this is going to be pi, or let's say the square root of 2 or the square root of 3. Those are all examples of irrational numbers. A rational number is a number that does make sense to you and can be expressed as a fraction. So 2/3, which is the same thing as 0.6666, or let's say -5, or let's say 1/3, which is going to be 0.33, repeating, or 1/2, which is going to be 0.5. Okay, those are all examples of a rational number. An integer is any positive and negative whole number, including 0. That is denoted with a z with an extra diagonal, and I always put a line in the middle, just so you know it's bold-faced. So again, make a z, put a line in the middle, and then add the extra diagonal. An example of this is going to be -15, 5, 2, 0. Those are all examples of integers. A natural number is any counting number. A natural number is going to be denoted by making, really did not want to extend the page there. How is this denoted? 2 lines down and make an n out of it. An example of this is going to be, these are your counting numbers. You start counting at 1, and then you keep going. Those are your natural numbers. Now, if you remember those stackable containers back in the day that you played with, real number system is something that looks like this. The real number is the mama number, and the mama had a set of twins, irrational and rational. Irrational is over here, rational is in here. Nothing fits in the irrational. Everything else fits in the rational. Integers fit inside the rationals, and naturals fit inside the integers. So the smallest cup is going to be your naturals, then you're going to have the naturals inside the integers, and then you're going to have the integers inside the rational, and the rational is going to be inside the real with its twin, the irrational, on the other side. Okay, so I'm going to give you a couple of examples. You're going to tell me how to classify these. So we're going to classify each variable according to the set of numbers that best describes its values. The school cafeteria serves chili every day. Which set of numbers best describes the value for the number of people P who order chili? Well, if you're ordering chili and you're a person, this is what we're going to do. We are going to be counting. So if we're counting, the numbers that are counting are the natural numbers, because you can physically count the people. And you can't have a half a person. You either have a person or you don't. The number of gallons of chili G sold. And it's a gallon. Gallons only come in whole numbers too. You have a gallon of milk. You can't buy a half a gallon of milk because that would be half gallons is what it would have specified. But it's specified in the directions as gallons. So again, you're going to be going ahead and saying the natural numbers because it says gallons. If it said gallons or half gallons, then you could have said your rational numbers. The number of students in your class is still the natural numbers because you're counting. The area of the circle, by using the formula, A is equal to pi r squared. So if that is pi r squared, A equals pi r squared. Pi indicates it's an irrational number, so that's what you would state is irrational. And then the elevation E of various land points in the United States measured to the nearest foot. 1 foot, 2 foot, 3 foot, 4 foot, 5 foot, okay? But it's elevation. Elevation can be very high up or it can be very low, meaning below sea level. So if it's above sea level and below sea level, this means we're going to be talking about our integers because it can be a whole number, but it can be both positive or negative, which is why you're using the integers. Okay? The next thing is graphing numbers on the number line. So if I'm graphing numbers on a number line, I first need to have a number line. Here's 0. Well, I need to know what negative 5 over 2 is, the square root of 2, and 2.6. Here's 1, here's 2, here's 3. This right here is going to be 2.6. We can estimate that very easily. Negative 5 over 2 is the same thing as negative 2.5, which is negative 2.5. 1, 2, 3. So that puts us right there to be negative 5 over 2. However, the square root of 2, well, this is where we need to kind of understand a few things. Well, how do we understand that? We understand this by doing perfect squares. So if I have 1 squared as being 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is going to be 81, 10 squared is 100, 11 squared is going to be, this is where everybody falls short, and this is why I want everybody to make sure that you memorize these, is going to be 121. 12 squared is going to be 144. 13 squared is going to be 169. 14 squared, swap the 6 and the 9, and that makes that 196. 15 squared is 225. Okay, these are the numbers that it would help you to memorize. Why? Because now we need to talk about square roots. So if I take the square root of 9, it is equal to 3. The square root of 25 is equal to 5. The square root of 36 is equal to 6. So in order to do the problem that we just were talking about, the square root of 2 is going to be between 1 and 4, right? The square root of 1 and the square root of 4. This is 2 and this is 1. Is it closer to 1? Does the square root of 2 fit closer to the square root of 1 or the square root of 4? It fits closer to 1, so this is going to be approximately right here, the square root of 2. So that's how you would graph those in a number line, and that's what you're going to use over there. Okay? That brings us to the next thing, which is how do you compare the square root of 50 and 8.8? Well, we are going to, again, use this over here, and we're going to say, okay, let's find our perfect squares. Well, 49 and 64 is where 50 is between. Would you agree? So that means the square root of 49 is 7, and the square root of 64 is 8. So that means the square root of 50 is between those. So if it's between those, which one is it closer to? Is it closer to the square root of 49 or the square root of 64, which is 8? It's going to be closer to this one. So the square root of 50 is approximately equal to 7, right? So if I would compare these two, that means that the square root of 50 is what compared to 8.8? Is it less than or greater than? Well, it is going to be less than that because it is closer to 7 rather than 8.8. I do not want you to put this in the calculator. I want you to use the logic, which is what I just did up there. Okay? Now, this is the big part of today's lesson. The big part of today's lessons is going to be our properties. Okay? And these properties are going to be the part that everybody usually struggles with. So, an axiom is a statement that you have to accept as being true. You can't do anything else about it but say, yes, this is true. So the very first property we're going to learn is going to be closure. The key to closure is you are going to see the words is a real number. This says if A is a real number and if B is a real number, that if I add A and B together, it will be a real number. Okay? It says if A is a real number and B is a real number, then A times B is a real number. Closure has the words is a real number. Associative property of addition and multiplication. Associative is going to be when the order stays the same. A, B, C equals A, B, C. A, B, C equals A, B, C. The only thing that moved on these were the parentheses. The parentheses moved from being around the B plus C in the first one to around the A plus B. Okay? So this means the order stays the same. Associative means the order stays the same. Super important. Okay, commutative. Commutative, if you are a commuter, That means you are going to school, and then you're going to turn around and come right back to school, right back home. You go to school and then turn around and come back home, which means this means that the order changes. You go from A plus B to B plus A. You change the order. The distributive property is going to be strictly distributing. A times B is AB. A times C is AC. Okay? Many of you see it on the left-hand side, but you do not see it when it's on the right-hand side. Okay, the identity. The identity is, what do I add to myself to get myself back? Well, if I'm going to add something to myself to not change myself, that means I'm going to add 0 to myself. What am I going to multiply myself by to get myself back? It's my identity. I'm going to multiply by 1. This is super important. Identity has 0 and 1 in it, but it equals itself. Okay? That is different than the additive or multiplicative inverse that also has 0 and 1 in it. However, it equals 0 and 1. What do I add to myself to cancel myself out? I add the opposite of it, which is going to be the minus A. And what do I multiply by? I multiply by the reciprocal to get myself back, which is going to be the 1 over A. So identity and inverse both have 0 and 1 in them. The key is identity means you want to get yourself back, and then for inverse, it equals 0 or 1. Okay? So let's go ahead and start some problems. This is tonight's worksheet. If we do number 1, AKN equals AKN. Did my order stay the same? It did, so therefore it's one of these. How do I know which one it is? Well, how are they attached? Are they attached by addition or multiplication? They're attached by multiplication, so therefore it's going to be B, associative property of multiplication. Okay, number 4. Number 4, I have 2n plus 3k plus 0 equals 2n plus 3k. There's a big clue in here, and the clue is there's a 0 inside of the problem. 0 or 1 means it's going to be identity or inverse. So how do I know which one it is? Well, inverse equals 0 or 1. Identity has the problem in it. So we know it's going to be identity, but which one is it going to be? Well, how are they attached? They're attached by addition. So this is going to be F for number 4. Okay? Number 6. Number 6. I have negative 5 plus 5 equals 0. Again, this has a 0 or 1 in it, so it's either identity or inverse, but because it equals 0, it has to be our inverse, and because they're attached by addition, it's going to be I, which is additive inverse. Okay? Number 9. Number 9, I have 3 parentheses 6t is equal to 6t parentheses 3. Did the order stay the same or change? 3, 6t, 6t, 3. The order changed. So since the order changed, that's kind of like going to school and turning around and commuting and going back home. So it's going to be the commutative property. The problem is it of addition or multiplication? In this case, it is going to be of multiplication, which means it's going to be letter D. Okay? Next, number 12. Number 12, k parentheses 3 plus 9 equals 3k plus 9k. Well, how am I getting a 3k out of this? Well, all they did was distribute that, so therefore it has to be letter E, the distributive property. Yes? Number 16, x plus 6 is a real number. As soon as you see is a real number, the dead giveaway should be J for closure. Number 19, 6b, 9c, 11e, 6b, 9c, 11e. Did the order stay the same or change? The order stayed the same, which means it is the associative property of addition. Okay? Okay, number 28. Number 28, 5 parentheses 1/5 is equal to 1. The dead giveaway on this problem is the fact that it equals 1. So which one of these properties equals 1? Is it the identity or is it the inverse? It is going to be the inverse. But how is the 5 and the 1/5 attached? By multiplication, so it's going to be letter H, multiplicative inverse. Okay? Properties. I cannot tell you enough how much you must practice this over and over and over and over again. Quizzes is something that is a great way to practice this. You can just Google properties, and it is magnificent. It gives you tons of them, and I actually have a exercise for you to do later on this week. Okay, next. On the back side of the worksheet says the number of times a ball bounces. So whenever a ball bounces, you drop it, and then it bounces up, and that's 1 time. The second time it bounces, it's going to be 2 times. So if you can count them, this will be the natural numbers. The height from which the ball is dropped, well, I can drop it at many different measurable heights. And a height doesn't say it has to be a foot, so that means it can be a decimal, and decimals are going to be rational numbers. Okay, 34 and 35 you can do. Then we're going to go ahead and to find the length of the side B, all you're going to do is simply plug and chug. So this is a plug and chug problem. They give you V and they give you H, and you plug it into this problem. So this is going to be 100 over 5. 100 divided by 5, I wrote that wrong, sorry, is going to be 20. Can you tell me, is 20 a perfect square? What do I mean by that? Is 20 in this list? 20 is not in that list. 16 and 25 are in the list, so since it's not a perfect square, that means that this is going to be an irrational number because it is not a perfect square. Okay? And that is how you are going to do tonight's homework. Any questions? If you have questions, please contact me and I will help you as best I can.